All right, really quickly then we have to just discuss what a counterexample is. And basically all a counterexample is a statement proving that whatever it is that you thought was true isn't true. And you only need to come up with one situation where it's not true to prove your whole idea is false, okay? So for example, if you remember this set of numbers we did at the beginning, we started off going, okay, well this looks like 3 times 1, 3 times 2. We go, oh, okay, well the term is just 3 times n, okay? But that's not true. So that one might be what we come up with, judging by the stuff that we looked at. But then a counterexample would be right here. We say, okay, well, but if you put in 3 times 3, it does not equal 12. Okay, and so that would be a counterexample, and where you show where there's a contradiction or there's something wrong with it, and you don't need to go any further than that to say no, you're wrong because look, it doesn't work all the time. Okay, that's generally what a counterexample is. There's lots of different ways you can use that. Here are some. Okay, so here's a statement here: multiplying two numbers yields a larger number. Okay, and that is often true. For example, okay, multiplying 2 and 3 gives you 6, larger than both 2 and 3. 32, larger than both 4 and 8. Okay, but it doesn't always work, and so a counterexample would be a case where it didn't work. For example, something like this. So 16 times a half is 8. 8 is less than 16, greater than a half, but less than 16. And 0.5 times 0.6 is actually 0.3, smaller than both of them. And of course, I can always multiply by 0, and that gives me 0, which is always less than any positive number. So obviously, these are all counterexamples, so then that initial statement we made here isn't true. So a statement can only be considered generally true if it works all the time, but obviously counterexamples would go ahead and prove that. So what I'd like you to do is to answer these two questions by bringing in a counterexample to each of those statements. So the first one is the second power of any number is an even number. So something squared will always be even. There's lots of counterexamples for that one. And I can only think of one counterexample for the second one. Any real number raised to the power of 0 is equal to 1. So see if you can figure out what that one counterexample is, and maybe you can bring two and surprise me. Who knows? Okay, that's it. We'll talk to you tomorrow.